now we come to another important problem. This is one important problem. So here fx is a cubic polynomial of exactly one real root, and fx with the antiderivative of fx. What exactly mean? The meaning is d dx of fx equals to small fx. You know the continuous fx is continuous because it's a polynomial and every polynomial is continuous. And we already know every polynomial of odd degree must have a real root. And this question has been asked from the polynomial, especially in classical algebra, and that has been set up in NET December 2023. It is memory-based question. So now the option are if capital Fx has exactly one real root, or all roots of Fx are real, and Fx is exactly two real root, and Fx has no real root. So now we come to the explanation. So here you can justify with the simple example. Okay, here you just think about your fx is clean. The condition is fx is cubic polynomial. Obviously, fx is continuous, and among degree, what is the degree? The degree is basically 3. And it has exactly one real root. So how to produce a polynomial with exactly one real root? So just you take fx equals to x. And here you just take one quadratic polynomial which has imaginary root. So just as for example x square plus x plus 1, or you can take like this fx equals to x, and take here this gives you a real root. This is 0, and here you just put a quadratic polynomial, and together they form a cubic polynomial because it's a multiplication and the roots of the quadratic is imaginary. So in that case, you can take x square plus 1 or x square plus 2, or you can take fx equals to x square plus 2023. No problem. In that, you can produce a cubic polynomial with exactly one real root. Now, fx equals to x cube plus x square plus x. So fx is a cubic polynomial, exactly one real root, 0. Now, calculate capital Fx. So, how that will be x to the power 4 by 4, x cube by 3, x square by 2. So, that means 1 by 12 into x square of. So what are the roots of capital Fx equals to 0? The roots is 0, 0, minus 2 plus minus root 5, 5. From that you will see capital Fx has two real root and two complex root, purely complex roots. So here Fx is exactly one real root. That means this option is discarded. All real root of Fx are real. This is also discarded. Fx has no real root. This is also discarded. So only one option is left. So obviously we know in every question at least one option is correct. So obvious option C is correct without any checking. But okay, you can prove it very easily. You can prove it in general. Now you can also check with the help of this polynomial x square x into x square plus 1 x cube plus x. You know this Fx has 0 and other root is plus minus I. And that means it is a cubic polynomial. Small fx is cubic polynomial of exactly one real root. What will be capital Fx? And you will see capital Fx again has two real root and two imaginary root. So that means what should be the claim? Our claim is if Fx is a polynomial of degree 3 with exactly one real root, and d dx of capital Fx equals to small fx, then capital Fx has exactly two real root. That you need to establish. You can prove it. This is your self-in exercise. Okay, with the help of a simple trick, a simple example, we can strike out the 3 options. So obviously the remaining option will be correct. So thank you so much.